Today we're going to talk about the margin for error or margin of error. Anytime we take statistics, whatever the case may be, we have some room in which we cannot measure. For instance, if I were to take a measuring stick and my measuring stick only measured inches and nothing in between, well, I would have a 0 inches and then I would have a 1 inches. Well, in this case, my margin for error, since I don't have any tick marks in between, my margin for error is half of that distance. I can't be off by more than half an inch. Because if I did measure this thing out, and let's say something fell to this point right here, I would know it's obviously closer to the 1 inch, so I would call it 1 inch, and I would be off by whatever amount that is. But I'm never going to be off by more than half of our unit of measuring. And this is called a margin for error. The same thing can be done throughout different examples. For instance, if I have somebody, and let's just say I'm running a race, and then they lap me one time. Well, one lap is 400 meters. Well, if I finish before they lap me a second time, they could have beaten me by 400 meters, 401 meters, excuse me, because that's a full lap, or they could have been about to lap me for the second time. Well, then my margin for error would be 401 to 799, because I'm not sure which one of those amounts we have. So when we deal with statistics, we are going to deal with a margin for error. So let's take a look at some of the examples and see if we can figure out our margin of error. So this example is on your Delta Math, so we'll take a look at these together. And it says, the study of a Department of Education of a certain state was trying to determine the mean SAT score, SAT score, of a graduating high school class of seniors. The students found a confidence interval for the mean score between 486 and 546. What is the margin for error on this survey? So basically what we've had here is we've set a bookend, and we know that it's 564 and 486. So we know we're going to fall between these two numbers. So what we're going to do is find the mean, which is directly in the middle of these two numbers. So the way we do this is we basically find the average of these two numbers. So what we could do is we could add them together and divide by 2, but I actually personally like to do it this way. The larger number minus the smaller number. And what that will do is tell me how far apart these two numbers are from one another. And they are 60 units apart from each other. So our mean is going to be half the distance of our 60 units. So that would be a plus 30 for this and a minus 30 for that. So our measurement mean would be 516. And we would write our margin for error as plus and minus 30 units. And that's what a margin for error is. This is how much we can be off once we've established where our mean is, and then again where our intervals are with that mean. So the next example we have on our Delta Math, it says a study by Department of Education of a certain state is trying to determine the mean SAT scores again. Students found that the SAT score, the mean SAT score was 503. With a margin of error of 23. So we know if our mean score is 503 and our margin for error is 23, we are going to subtract 23 from this amount, and we would find our lower parameter is 480, and then we would add 23 to this amount, and we would see our higher limit is 526. So this is our intervals from 540 to 480 to 526. So it says, which of the following is a reasonable value for the true mean for the SAT score for a graduating high school senior? So we are going to look for an amount that falls between this interval. 477 is too low. 529 is too large. 534 is too large. So the only amount that we see that falls within our parameters is 489.4. In our last example, we're going to study the Department of Education, state, and try to determine the mean SAT score of a graduating senior class. The studies found that the mean score was 477 with a margin of error of 21. Write a confidence interval for the true statement of the SAT score for the graduating class of the high school seniors. So our mean score is 477 with a margin for error of 21. Well, the higher margin is just going to be to add 21 to this amount, which would take us to 458. And then our lower mean score is going to be subtracting 21, which would take us to 426. So our confidence intervals would be between 426 and 458. All right, as we take a look at this, when it says students at high school will vote for a proposal to start the school year dates. According to the survey, a random sample of students, 54% students agree that with the proposal, 46 disagree. When the survey's margin for error was plus or minus 5, and then it asks us what was the confidence interval for this survey? Well, it's a plus or minus 5. So if we're talking about the confidence interval of the survey in agreement, our agreement would be plus 5 and minus 5. Minus 5 would take us down to 49%. Plus 5 would take us up to 59%. So that would be our confidence intervals. It says on part B, if the sample used the survey contained 45 students, approximately how many of the students would we expect to agree with the proposal at the start of the year? Well, we have ours broken down into percentages, and our margin for error tells us we should expect from low end 49% and then high end 59%. So if we had the low end, 49% of our 45 students, that would be 22.05. So we would be looking at 22 students. And if it was the high end, 0.59, we would multiply that times our 45 students, excuse me. And then our high end would be 26.55, which would round up to 27. So we would expect anywhere between 22 and 27 students to agree with the proposal. Now, this part C says, when confidence intervals overlap, a survey does not clearly project the outcome of the voting. Does this survey clearly project the outcome? Well, our approved was 49 to 59%, and our disapproved with a mean of 46, the high end would be 51 and the low end would be 41. And we do clearly have an overlap because this one is 49% and this one is 51%. So we have an overlap of these two by about 3 degrees, the 49, the 50, and 51. So in our example here, does the survey clearly project an outcome? The answer would be no, because we do have overlap within our projections.